Have you ever wondered how a PCB actually becomes a fully assembled PCBA? A few weeks ago, AIVON received a new order from Aura Sensae, a company that develops safety systems for industrial robots. They were curious about how their boards are manufactured in the real world, so we decided to document the process. Right now, it's just a bare PCB. Before it leaves the factory, it will pass through inspection, assembly, soldering, and quality control before becoming part of a robotic safety system. Let's follow its journey through the factory. The board's journey begins with process verification before a single machine turns on. Here, engineers conduct a design for manufacturability review, verifying the Gerber data against double-sided SMT and THT constraints to establish the baseline programming for the printers and placement machines. Simultaneously, the manufacturing cycle commences at incoming quality control. Inspectors verify component lots against the customer BOM, checking lead planarity and surface oxidation under magnification to ensure baseline solderability. During this stage, the operator also performs a physical footprint check, placing sample components directly onto the bare PCB pads to verify that the component dimensions, pitch, and pin layouts match the board's physical footprint perfectly. Before production begins, operators perform a final material verification check. By comparing the real information against the production records, they confirm that every feeder position contains the correct component specified in the customer's bill of materials. This additional verification step helps eliminate loading errors before the first board enters the line. The bare board now enters the active production line, arriving at the stencil printing station. The immediate challenge is applying a precise volume of solder paste to hundreds of microscopic copper pads. If the paste is too thick, it will bridge adjacent pins. If it is too thin, the joint will crack under industrial vibration. The automatic printer addresses this by driving a squeegee across a laser-cut stainless steel stencil, depositing paste onto the exposed copper. To ensure accuracy before permanent assembly occurs, the board moves directly into the SPI system. The scanner projects structured light across the board to measure the exact height and volume of every paste deposit. This step protects the substrate from progressing further with underlying printing defects. With the solder paste verified, the board advances to the component placement stage. Small passive components, such as capacitors and resistors, must be populated by the thousands without delay, while large integrated circuits require slower, microscopic alignment. The factory splits this task between two specialized machines. First, the high-speed placement head uses vacuum nozzles to source and deposit smaller passive parts onto the sticky solder paste. Next, an internal vision camera scans the component from below, measuring the exact angle of its pins. The system corrects any rotational misalignment in midair before placing the controller onto the board, ensuring perfect pad alignment for both tiny resistors and dense silicon chips. At this point, the components are merely resting on wet paste. Before the entire production run enters the oven, the operator conducts a first article inspection on this initial board. Once approved, the batch enters the multi-zone reflow oven. To manage thermal stress, the board travels through highly calibrated stages of preheat, soak, reflow, and cooling. This gradual temperature profile safely liquefies the solder alloy, forming stable metallurgical bonds across every connection point before controlled cooling solidifies the joints. Now out of the oven, the board contains hundreds of freshly formed solder joints. The manufacturing challenge shifts to verification, how to confirm that every single connection is structurally sound. Manually inspecting thousands of joints across an entire batch would invite human fatigue. The factory solves this by routing the board into the post-reflow automated optical inspection system. Using multi-angled LED lighting, the system captures high-resolution images of the assembly and compares them against verified geometric parameters. It scans for hidden anomalies like component shifting, lifted leads, or solder beads. If the software flags a questionable connection, an operator or quality engineer reviews the image on a terminal, applying human expertise to determine if the joint meets IPC structural standards before letting the board leave the SMT area. The topside SMT process is finished at this stage. Operators flip the boards and repeat printing, placement, reflow, and AOI procedures to guarantee consistent high soldering quality on the bottom side. After double-sided mounting and AOI, the PCB surface mount process is concluded. The assembly next enters the THT department. Here, an inspector completes a first article review, cross-referencing component positions with the bill of materials to eliminate any mismatch before assembly begins. To maximize efficiency across different batch sizes, the factory utilizes a flexible production strategy. Depending on the order volume and design constraints, engineers route the boards to either automated wave soldering or dedicated manual soldering stations. Here is a look at the manual soldering process. To protect the onboard microcontrollers from electrostatic discharge, the technician operates with a grounded ESD wrist strap. After applying flux, they employ a standardized soldering technique, holding the iron tip against both the lead and pad for uniform thermal transfer. This allows the molten solder to fill the through hole completely via capillary action, forming a solid fillet with a clean wetting angle that meets IPC reliability guidelines. Before leaving the production floor, the assembly passes through final post-processing. To prevent long-term electrochemical corrosion from chemical residues, the board undergoes a dedicated cleaning stage to remove any invisible contaminants. The manufacturing cycle concludes at the final quality control station. A quality inspector performs a final visual audit under magnification, checking the physical integrity of the substrate and mechanical interfaces. Once approved, the completed safety controllers are sealed inside static shielding ESD bags and placed into shock-absorbing, protective packaging designed to prevent physical or electrical degradation during transport. This production lot for Aura Sensae is now complete and prepared for shipment. Only a few hours ago, this assembly was nothing more than a bare PCB. After passing through inspection, assembly, soldering, and verification, it is now ready to perform the task it was designed for. Soon, it will become part of an industrial safety system, helping monitor the interaction between people and machines in real-world production environments. Thanks for watching. Due to video length limitations, processes such as wave soldering, X-ray inspection, and automated through-hole insertion were not covered in this episode. We'll dive deeper into those in future videos. If you enjoyed the journey, hit the like button, share it with others, and drop a comment telling me which production process you'd like to explore next. Catch you in the next video.